we are going to see about the concepts of decoder and encoder and types of it. Okay, so first, what is meant by a decoder? Basically, it is a combination logic circuits. It is accepting a set of inputs from A0, A1 up to An-1 that representing a binary number. For that corresponding input, it produces the output. So all other outputs remain inactive. So only the corresponding output will be active at that time. Okay, so it's having n inputs and m outputs. For each of these combination, only one output will be active. Okay, first type is 2:4 line encoder, 2 inputs and 4 outputs. So 2:4 means we are representing the inputs first, then the outputs. Okay, so the combinations of the inputs are xy, so 0 0 0 1 1 0 and 1 1. 4 inputs, as we already discussed. For many combination of inputs, we are going to get only one input only. Okay, so A0, A1, A2, A3 are the outputs. So for particular this input combination, only one output will be enabled, remaining things will be 0. For 0 0 it is A0, this is enabled. For 0 1, A1 is enabled, 1 0, A2 is enabled, 1 1, A3 is enabled. So this is a logic diagram representation. So for that A0, for all the outputs, we should represent the combination value. So A0, that is x bar, y bar. Then A1, that is x bar, y. A2, it is x, y bar. A3, it is x, y. So only for 3:8. So 3 means 3 inputs and 8 outputs. So it represents x, y, z. Then 8 outputs. So A0 to A7. This is the combination. So 3 inputs. We already know the 3 input combinations. Starts from 0 0 0 0 0 1 up to 1 1 1. Okay, so it starts from A0 to A7. So for this particular input combination, this one remains. For this one A1, this one A2, A3, A4, A5, A6, A7. So for a particular input, only that concerned output will remains in high state. Remaining things are 0. As these are all the outputs. So the equation has been calculated as follows. Logical diagram has been drawn for that. If it is x bar, y bar, z bar means first we should draw x, y, z. Then that with the help of NOT gate, x bar has been drawn, y bar, z bar has been drawn. Okay. Then by using AND gate, we find out this x bar, y bar, z. The important concept is BCD to segment decoder or BCD to 7 segment decoder. Okay, so you all know about the digital number representation. So in digital number representation, we are having 7 segments. So this is A, B, C, D, E, F, and G. Okay, clockwise direction. So for number 3, in LED segments are in on state. So A, B, C, G, and D. That's why they have mentioned 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for the corresponding inputs that we are providing, what are all the outputs that are in on state that we have to represent? Okay, so the BCD inputs are from combinations 0 0 0 to 1 0 0 1. Okay, that's why they represented in ABCD, 4 inputs. Okay, these are all the 7 segment outputs. Understand this truth table. So the BCD input, it is a BCD to 7 segment converter decoder. Okay, so A, B, C, D. Why we are representing from 0 0 0 to 1 0 0 1? Because for BCD the input starts from 0 to 9. Okay, so when 0 is low means what are all the output combinations are in high state. So A, B, C, D, E, F are in high state. The G is in low state. Okay, so similarly for 1, this PC only enabled, remaining things are 0. For 2, that is A, B, D, E, G. Okay, similarly for 3, 4, 5, 6, 7, 8, 9. After completing these two tables, for all the outputs, we should plot the K map. Okay, after plotting the K map, when we simplify this, we will get separate equations for all the output values. Okay, so we should create a logic diagram for all the outputs. Okay, using these equations. Okay. So this is the combinations A, B, C, D, and these are all the outputs. Then encoder. So in case of encoder, this is also a combination circuit. It works opposite to that of decoder. Okay, here it is a reversible of decoding process. It turns a live signal into a coded output. Okay, so that X represents the input and Y represents the output. M input values and N output values. So as an encoder, it has X input values, but only one of them is active at a given moment. And it generates a Y value. Decimal to BCD encoder. So decimal value, so 0 to 9. The BCD A, B, C, D. The input starts from 0 to 9. As we already mentioned, only that state is present. Remaining things are 0. So this is the input combination and this is the output combination. For this input, it starts from 0. For this, it is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So from the truth table, we clearly understand that when the output is high, so when the output is 8 or 9, that is high. So it is 8 plus 9. So when the output B is high means it should be 4 or 5 or 6 or 7. Okay, therefore 4 plus 5 plus 6 plus 7. When output C is high means that is 2 or of, 3 or of, 6 or of, 7. Okay, so C is 2 plus 3 plus 6 plus 7. Similarly for D it is 1 plus 3 plus 5 plus 7 plus 9. So we have to draw the diagram for inputs values. We are getting the output BCD values.